So hello and welcome to the final project assignment. This is the setup. This is the 3D filament drying solution, I would call it. And you may notice it looks different than what I had in the beginning during the proposal, since the proposal idea was actually just a solution for surveillance. So to observe the conditions for the filament to dry in, while as this solution here takes action and adjusts the environment, or at least the climate inside of this box, to its needs. So whatever material is used, it can adjust it itself, and it will dry the filament for multiple hours until until it's dry. Maybe first up, why is it even needed? So I have here an old roll of filament, and this goes usually right into this printer, and it pulls it, and then here's a hot nozzle that uses it. And the problem is that once it's stored up there at this construction, it attracts all the moisture from the environment here in my room. So I was forced to buy this quality filament dryer, but I find them pretty expensive. So I thought this is a cool idea to actually do something like a cool project. So this is the filament, and it would come right here. It would sit right on top of that, or like in between, like this goes through the hole. And but yeah, let me talk first about the setup here. So we have a 12 volts 5 ampere power supply, which goes directly to the power socket. Then we have this unit here. I would call this electronics unit. It houses all important electronics, like starting with the buck converter. We have the nano. I used a Arduino Nano for that. We have a rotary encoder, we have the I2C module, and we have this LCD 16x2. What it also houses is, like I had to implement a lot of protective components in order to protect the electronics from the high current. We have a 4700 microfarad capacitor. Also we have a capacitor 1000 microfarads at the beginning of the back of the like in ports of the buck converter, as well as a ceramic capacitor for the higher frequencies, which like usually it's above 1 megahertz. So when we have a look here, what do we see here? So the electronics box is supplying all the cables which go here. We have here the 3 MOSFET modules. It says fan out, fan in, and the back one is heater. So as you can see, we have a vent hole. This is here, the air vent. And this is basically direct opposite, so there's no vacuum inside this box once it's closed. We have here the heating component, which also has a fan integrated in the back. So it basically blows the hot air through this heating element into the inner environment. This here basically just goes like that, and it holds it in place. And yes, this is how it looks like. It's a bit chaotic, but I think I did a pretty good job in managing all the cables. Also, we have the temperature sensor. It's right here, since hot air is coming up to the top. So yeah, we can move on to the menu. This is the menu. We can choose between multiple filaments. I just used now these 3 because I'm using these actually: ASA, PTG, and PLA. And let's use PTG for now. Once I push the button, now I can change the time And once I hit the button again, the heater and the integrated fan should actually start working. And now this is the case. So they work, they illuminate it, and we have here a timer that goes backwards. And now the temperature will adjust and it will rise up to 60 degrees Celsius. And I can also forcefully abort it by just pressing again. Now we have a cooldown. It says cooldown active. And now also this fan became active. And now they're blowing like a lot of air through here in order to cool the system down. And especially to cool the heater down. While you have noticed now that the heating, now the last module became inactive, while fan 1 and fan 2 became active. So they're both working now for 30 seconds. Now they have cooled down. And I can start over or pick another filament. Meanwhile, this is crucial to pick the right one because they all dry with a different temperature and you should not overshoot the target. Usually also during the heating process, this fan becomes active as soon as we are close to the target. Like I think I implement minus 10 degrees. So it blows all the moisture out. And I can also show it again. Now I let it start. Now you can see this wonderful solution here. While this fan actually pushes the slats, so all the moisture and all the hot air can escape from here. While this fan actually, it's a bit restricted in its capabilities. It has 200 ohm resistors in parallel. And this was my intention in order to keep most of the hot air inside while just blowing out the moisture. Also worth mentioning, each component has its own ground because I previously had problems with the electronics since there is some occurrences like ground bounce, and now I implemented in German it's called Sternmasse. So we have a single neutral point where they all meet, and it's basically the negative of the 4700 microfarad capacitor, and all the other different components, they meet at the negative of the capacitor, so the hardware is protected. And this was quite of a challenge in order to to organize every wires, like all the wires on every path. And as you can see, it's very crowded in here, but somehow I think I did a good job in managing all the cables. And also on the road to actually see that problem, I almost created a fire 2 times. This is crazy, and I think the bug started smoking, so I exchanged it. But it has 12 volts and input and 5 volts output, and I measured it. This one is fine and it works. And I mean, I wouldn't use the device, of course, like without being next to it, because I don't want to cause any fire. But what I learned from the project is that the theory is one thing, but actually having the hands on it, it's different. And there's so many sources of errors you can do. And yeah, I had to learn it the hard way, but I'm glad I made it up to here. So yeah, this is the system. I hope you like it. For the box, I just used an IKEA box. There's a couple of people who said that it's quite important to not use a too big one, because otherwise this heater just takes years in order to heat up the environment. I used a 10.5 liter, I think it is, from IKEA. But I could have also printed it. It's just very time consuming to print it all, and I think it's not necessary at all. While I just printed this housing, and I used the plexiglass in order to protect the components here. And as you can see, the knob goes actually through the glass, which is kind of cool, I think. And also here for the air intake, it's protected from the outside, while inside it has these slats, so the heat stays inside. It's basically trapped until I want it to escape, then it would escape only from here. So yeah, and once I would like implement it like fully in its size, I would just place one-handed. It's a bit tricky, but I would just place this one here on top, and then it would look like that. So yeah, this is the project. I hope you like it, and yeah, if you have any questions, then please let me know.